So I was contacted a few days ago by some Brazilian and Argentinian engineers and designers who were working on a manual ventilator. And they had picked up some of my valves, thanks guys, and solved some of the problems that I had been working on. I went through about 4 prototypes of different types of pump bags to run through the last check valve that I made. None of them worked, and the Brazilians and Argentinians figured it out with a inner tube from a truck and some laser cut parts or hand cut parts. Anyway, one of the really important pieces of a ventilator system is controlling high pressure in and low pressure, but still some pressure out. And so in an ambu bag, there's a thing called a duck valve, or a duckbill valve, which is basically a piece of silicone that comes to a point with a slit. And so when you pump high pressure in, it opens up like this. And then when you stop putting pressure behind it, it closes back on itself. And if there's ever pressure coming from this direction, it just squeezes it tighter closed. You can find a duckbill valve in sewage and sanitation systems, and you can also find it in a breast pump. It's not a very complicated valve, but the deal is, in an ambu bag, it works in a very special way, where when the duck valve opens, it actually closes ports on the side that allow people to exhale through the PEEP system. So when it opens, the pumped air cannot exit through the low pressure PEEP, which is the positive end exhalation pressure valve system. That's a really simple and clever solution. I've been working on ways to replace the ambu bag in a lot of these designs that rely on it. And so I can cast silicone here. I have some pressure pots and such, but it's not an easily made part. And again, hopefully somebody will injection mold 1,000,000 of them and there'll be no need for this. But I was trying to think of a valve that would do the same thing, but made with really simple parts. And so I came up with this. And this could be retrofitted into, some very small 3D printed or laser cut or even hand cut pieces into some PVC pipe, but I've got some 3D printers, and this entire valve system probably comes off in about 3.5, 4 hours on one printer, much less for me. Okay, so what this does is this purple hose barb goes to the patient, this goes to the PEEP or exhalation system, and this goes to the pump. And so when you blow air through the pump at high pressure, it blocks the PEEP system, so the high pressure air can't just exit through the low pressure output, and allows air to flow high pressure to the patient. Then when the piston is refilling, or the ambu bag is refilling, and the patient is exhaling, it blocks this port down here, the black port, and allows air to exit through the yellow port. So let's see if I can do a little demo here. So the valve needs to be in this orientation because it uses some gravity on a diaphragm that sits between the yellow and black ports. So if I blow air into the black port, it will exit here, and this will not transmit any air. So there's air flowing here. Let's see if I can do it with something like a glove. Let's see. I'm just going to take the finger of this glove to show you where air is moving. So if I blow into the black port, air comes out the purple and does not come out the yellow. And again, if I blow in the purple port, air will come out the yellow and not the black. So if I put this glove over the yellow port, it comes out. And if I put the glove, let's see, how am I going to do this? Here, blow in the purple port as the patient exhales. You can see no motion in the glove. And I'll take this apart in just a second so you can see how it works. Okay, so this valve is made of 4 pieces and 1 screw. It's the main purple valve body, the yellow exhalation port, and the black intake port. You can print them in any color, obviously. Let's take them apart. So this works a lot like the PEEP valve that I designed earlier, with a fixed diaphragm blocking an orifice plate. Again, I suggest you don't use that PEEP valve. Tube and water should work better. This is the high pressure in, and you can see this plate, or this hose barb, has some, I don't know if you can see it. It looks a lot like this. It has a bunch of holes, orifices on this very smooth plate. That's important that you print both of these plates down on the printer so that if you print them on glass, they're nice and smooth and make a nice seal. And then there's just a little screw here. This is an M3 hex screw that this disc, this diaphragm, can ride up on when blown up. And it just uses gravity. I don't know if you can see that. And if I blow on it, let's see. So that disc moves up when there's high pressure. And these two are sitting inside the valve body close enough such that when this disc moves up, it seals the orifice plate here. Then inside the body, there's basically just a tube for the 2 orifice nozzles to come close together, a couple of millimeters apart. And then, it's kind of hard to see, but there are channels in the side of this thing that go out to this port. You could also make this with some 3D printed parts, or again, cut parts, or even hand cut parts with a standard PVC T. And there's no reason why this port has to go up instead of out. Aside from just the geometry of 3D printing, this works a whole lot better. The only thing that's geometrically important is that this intake port is facing up so that the weight of this little stopper brings it down when there's no pressure behind it. I thought about using a spring, but it's really kind of tricky in this space to get the right tension spring so that it reseats this plate down against the orifices. But it seems to work really well with just the weight of this disc. So this is the valve body, the diversion valve that I built. You can see in light blue, here is the body. In purple, this is the output orifice to the PEEP system, or the exhalation orifice. And then this in blue is the high pressure orifice. This comes from the pump to the patient. And then in red here, we can see the diaphragm that will move up and down. Basically, there's these orifice plates in these little holes in here in both the inhale and exhale nozzles. And then when there's high pressure coming from this blue orifice, it pushes this diaphragm up until it hits the purple orifice and blocks that and allows air to flow out through the light blue orifice over here in the valve body. You can see that there's a channel inside of this piece leading out to this port that goes to the patient. Yeah, so I don't know of any other diverter valve that works like this, where you can blow in one side and it comes out another, and then if you blow in the other, it comes out a third port, other than the Ambu bag. Let me know in the comments if there are other commonly available valves that do this. But for now, if you are designing a system, you can go to the Onshape file in the link in the description and download it and print one yourself if you are a machine designer. Again, do not go printing these if you are going to just donate them to a hospital. It is not a useful part to any machine that they have. It hopefully will be a useful part to some machines that designers and engineers are working on, crowdsourced and open source around the world. Anyway, I hope this is helpful, and thanks for watching.